few recommended theory books for electrical fundamentals include Electrical Principles and Practices by Charles I. Hubert and Lynn R. Cox, Electrical Wiring Residential by Robert Traister, Fundamentals of Electricity for Technology by Stephen J. Herman, The Complete Idiot's Guide to Electrical Wiring by Edward L. Safford and Guy C. Hammond Jr., and Ugley's Electrical References, 2023 by Charles R. Miller and Richard A. Miller. A good theory book typically covers the following topics. Firstly, basic electrical concepts, including current, voltage, and resistance. Secondly, Ohm's law and circuit analysis. Thirdly, alternating current and direct current circuits. Fourthly, transformers and inductors. Fifthly, capacitors. Sixthly, electrical measurements and instruments. Seventhly, electrical safety. And eighthly, National Electrical Code requirements. To learn electrical theory effectively: 1. Start with the basics and gradually increase the complexity. 2. Practice solving problems and applying the concept. 3. Seek assistance from experienced electricians or online resources. 4. Study regularly to reinforce understanding. And 5. Don't be afraid to ask questions and clarify any doubts. Basic electrical concepts form the foundation for understanding more complex electrical systems. Current is the flow of electrical charge, typically measured in amps. Voltage is the electrical potential difference, measured in volts, that drives the current. Resistance, measured in ohms, opposes the flow of current. Ohm's law describes the relationship between voltage, current, and resistance, stating that voltage equals current multiplied by resistance, often expressed as volts equals amps times ohms. This fundamental law is crucial for analyzing and designing electrical circuits. Circuit analysis involves applying Ohm's law and other principles to determine the voltage, current, and resistance in different parts of a circuit. Series circuits have components connected in a single path, so the current is the same through each component, and the voltages add up. Parallel circuits have components connected in multiple paths, so the voltage is the same across each component, and the currents add up. Alternating current, or AC, is electrical current that periodically reverses direction, while direct current, or DC, flows in one direction only. AC is commonly used in household and industrial power distribution, while DC is often used in electronic devices. The key difference between AC and DC lies in the way the voltage and current change over time. AC voltage and current vary sinusoidally, while DC voltage and current are constant. Transformers are devices that transfer electrical energy from one circuit to another through electromagnetic induction. They consist of two or more coils of wire wrapped around a common magnetic core. Transformers are used to step up or step down voltage levels, which is essential for efficient power transmission and distribution. Inductors are passive components that store energy in a magnetic field when current flows through them. They consist of a coil of wire and are used in circuits to filter signals, store energy, and create resonance circuits. The inductance of an inductor depends on the number of turns in the coil, the core material, and the geometry of the coil. Capacitors are passive components that store energy in an electric field. They consist of two conductive plates separated by an insulator called a dielectric. Capacitors are used in circuits to filter signals, store energy, and provide timing functions. The capacitance of a capacitor depends on the area of the plates, the distance between them, and the dielectric material. Electrical measurements and instruments are essential for diagnosing problems and ensuring the safe operation of electrical systems. Common instruments include voltmeters, ammeters, ohmmeters, and multimeters. Voltmeters measure voltage, ammeters measure current, and ohmmeters measure resistance. Multimeters can measure voltage, current, and resistance, as well as other electrical parameters. Electrical safety is of paramount importance when working with electricity. Always follow safety precautions, such as wearing appropriate personal protective equipment to energizing circuits before working on them, and using insulated tools. Branding is an important safety measure that provides a low resistance path for fault currents to flow back to the source, helping to prevent electric shock. The National Electrical Code, or NEC, is a set of standards for safe electrical installations. It provides guidelines for wiring methods, overcurrent protection, grounding, and other aspects of electrical systems. The NEC is updated every 3 years, so it is important to stay current with the latest edition. Understanding the NEC requirements is crucial for ensuring that electrical installations are safe and compliant with regulations. The NEC covers a wide range of topics, including wiring methods, conductor sizing, overcurrent protection, grounding, and equipment installation. Specific articles within the NEC address different types of occupancies and equipment. For example, Article 210 covers branch circuits, Article 220 covers branch circuit, feeder, and service calculations, and Article 250 covers grounding and bonding. When working with electrical systems, it's important to follow the NEC guidelines to ensure safety and prevent electrical hazards. Different types of wiring methods are covered by the NEC, including non-metallic sheath cable, often referred to as Romex, metallic conduit, and cable tray. Each wiring method has its own set of requirements for installation and support. Conductor sizing is critical for ensuring that conductors can safely carry the intended current. The NEC provides tables for determining the ampacity of conductors based on their size, insulation type, and ambient temperature. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. The NEC specifies the maximum overcurrent protection for different types of circuits and equipment. Grounding and bonding are essential for providing a low impedance path for fault currents, which helps to protect people and equipment from electrical shock. The NEC outlines the requirements for grounding electrodes, grounding conductors, and bonding jumpers. Equipment installation must comply with the NEC requirements to ensure that it is installed safely and correctly. This includes requirements for clearances, ventilation, and support. Studying electrical theory regularly is essential for reinforcing your understanding and staying up to date with the latest advancements in the field. Set aside dedicated time each week to review the material and work through practice problems. Don't hesitate to seek assistance from experienced electricians or online resources when you encounter challenging concepts. There are many online forums and websites where you can ask questions and get help from other professionals. Remember, learning electrical theory is a continuous process, so stay curious and keep learning. One should always begin with fundamental concepts. Understanding current, voltage, and resistance is the foundation upon which all other electrical knowledge is built. Ensure you grasp these concepts thoroughly before moving on to more advanced topics. Next is to solve practice problems. Applying what you've learned through practice problems is essential for solidifying your understanding. Work through a variety of problems to develop your problem-solving skills. One might also seek guidance from experienced professionals. Don't hesitate to ask experienced electricians or instructors for help when you encounter challenging concepts. Their insights and explanations can be invaluable. There are also several resources available to supplement your learning. Utilize textbooks, online resources, and hands-on training to enhance your understanding of electrical theory. Furthermore, consistent review is key. Regularly review the material to reinforce your understanding and prevent knowledge gaps. Electrical theory is a vast and complex subject, so continuous learning is essential. Never be afraid to ask questions. Asking questions is a sign of curiosity and a desire to learn. Don't hesitate to ask questions whenever you're unsure about something. Also, relate theory to practice. Wherever possible, relate electrical theory to real-world applications. This will help you understand the practical implications of the concepts you're learning. Moreover, stay updated with the NEC. The National Electrical Code is constantly evolving, so it's important to stay updated with the latest revisions. This will ensure that your knowledge is current and compliant with industry standards. It is also beneficial to attend workshops and seminars. Consider attending workshops and seminars to learn from industry experts and network with other professionals. These events can provide valuable insights and practical knowledge. When dealing with complex concepts, try breaking them down into smaller, more manageable pieces. This will make it easier to understand and retain the information. Create diagrams and visual aids. Visual aids, such as diagrams and flowcharts, can be helpful for understanding complex electrical concepts. Create your own visual aids to reinforce your understanding. Join study groups or online forums. Connecting with other learners can provide valuable support and encouragement. Join study groups or online forums to share ideas and ask questions. Experiment with simulations and virtual labs. Simulations and virtual labs allow you to experiment with electrical circuits in a safe and controlled environment. This can be a valuable tool for learning and understanding electrical theory. Use mnemonic devices to remember important formulas and concepts. Mnemonic devices can be helpful for remembering important information. Create your own mnemonic devices to aid in memorization. Stay patient and persistent. Learning electrical theory takes time and effort. Stay patient and persistent, and don't get discouraged by setbacks. Consistent effort will eventually lead to success. Another area to focus on is understanding single-phase and three-phase power systems. These are the most common types of power systems used in residential, commercial, and industrial applications. Single-phase power systems have two wires, a hot wire and a neutral wire, while three-phase power systems have three hot wires and a neutral wire. Three-phase power systems are more efficient for delivering power to large loads. One should also understand the operation of electric motors and generators. Electric motors convert electrical energy into mechanical energy, while generators convert mechanical energy into electrical energy. Understanding the principles of operation of these devices is essential for working with electrical systems. Be sure to study the different types of electric motors, such as induction motors, synchronous motors, and direct current motors. Each type of motor has its own characteristics and applications. Also be sure to study the different types of generators, such as synchronous generators and direct current generators. Synchronous generators are commonly used in power plants, while direct current generators are used in some specialized applications. Familiarize yourself with control systems. Control systems are used to automate and control electrical equipment. These systems can range from simple on-off switches to complex programmable logic controllers. Understanding the basics of control systems is essential for working with many types of electrical equipment. Study the different types of sensors and actuators used in control systems. Sensors provide feedback on the state of the system, while actuators control the operation of the system. And consider delving into power electronics. Power electronics is a field that deals with the control and conversion of electrical power. Power electronic devices, such as rectifiers, inverters, and converters, are used in a wide range of applications, including motor drives, power supplies, and renewable energy systems. Gain knowledge of grounding and bonding techniques. Grounding and bonding are essential for electrical safety. Grounding provides a path for fault current to flow back to the source, while bonding ensures that all metal parts of an electrical system are at the same potential. The National Electrical Code provides detailed requirements for grounding and bonding. It is good to be aware of the hazards associated with electricity, such as electric shock, arc flash, and fire. Follow safety precautions when working with electrical equipment to prevent accidents. De-energize circuits before working on them and use insulated tools and equipment. Wear appropriate personal protective equipment, such as safety glasses and gloves. Consider participating in hands-on training programs to gain practical experience in electrical work. Hands-on training can help you develop the skills and knowledge needed to work safely and effectively with electrical systems.